Hey everyone, this is Kalpa here and welcome to my channel AI Connect Grow. If you're new here and want to become an AI expert, please don't think twice. Click on the subscribe button and get notifications for all the videos and blogs that I'll be creating for you. If you also go to the aiconnectgrow.com and if you click on the blogs, you can find all my blogs, and if you click on the YouTube link over here, it'll straight away navigate to my channel. So now, without any delay, let's start with today's topic. So this particular blog I've written for beginners who are thinking like how I can go ahead and learn about AI and machine learning. What are the resources I need to refer? So for you, I've come up with this excited blog wherein you'll be getting complete end-to-end information. So here in this blog, I have focused on machine learning, deep learning, large language models, and MLOps. I've explained what is artificial intelligence, what are some of AI applications, and what is machine learning, and what are the some of the applications that you can implement using machine learning models. And I've also given you details about the languages and frameworks that you need to learn, like Python and libraries like NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, TensorFlow, PyTorch as such. Just before I proceed further, I want to give you an advice that please don't be overwhelmed. Whatever I'm saying here is super easy, and I'll be creating blog for each one of these things. So here in this blog, it's just an insight for you, like what are the topics that are very important and what are the topics that you need to know to become an AI expert. But all of these are very simple and easy to learn, which you can do within 3 months. If you follow all my blogs within 3 months, you will be able to become an AI expert. Next, let's discuss what are the building blocks of AI and ML. So the most important things that you need to know before you go ahead and implement machine learning models are a bit of statistics and probability. Not that you have to become an expert, but then it's great to know these things so that you can do the data collection, data analysis, and be able to interpret the model output, understand the likelihood of the events that occur. So it's very important for you to understand a bit of stats and probability. For that, I've given you a very good resource like Khan Academy, StatQuest channel, and Coursera Statistics and Probability. You can choose any one of these resources because they have really explained in very simple term, giving you all these images and making you understand each and every bit of statistics and probability. So this is a very good resource for you to go ahead and choose from. And the next, once you understand stats and probability at a very high level, make sure you learn about algorithms. So what are these algorithms? So unlike in traditional programming, wherein people were writing explicitly giving writing programming to do a specific task, here we make use of machine learning algorithms to learn the pattern within the data. So in order to do that, you need to know like what models I need to be using to solve so and so problems. So in order to do that, you need to know what is supervised learning, what is unsupervised learning. At a very high level, supervised learning is wherein you have the label. For example, if you're building a model to predict diabetic, whether a patient is going to be diabetic or not, you already have historical data wherein you know that so and so person was diabetic, and you make use of, and so and so person was not by diabetic, and you make use of this historical data to build a model. So this is called supervised learning, wherein you have label for the data and you build models on top of it. And next, coming to unsupervised learning, wherein you do not have a label. For example, a retail company, if they want to categorize their customers into high-end customers or low-end customers, they just go ahead and make use of unsupervised models to cluster or to group their customers into high end and low end based on the patterns within the data. So this is unsupervised learning where you do not have label. So within supervised learning, wherein you have label, the problem can be further categorized into regression and classification. So regression is where you have the label and you're trying to predict a numeric continuous value. For example, if you're trying to predict a price of the car or maybe a salary of a person, so this particular label is a numeric continuous variable, right? So this is called as regression problem. Whereas classification problem is in where you are trying to classify whether, for example, an email is spam or not. Is this particular person fraud or not? You basically have historical data wherein you build the model to predict and classify into certain categories. So that is called as classification problem. So now that we understood about at a very high level about supervised and unsupervised, like you can go ahead and choose models. Once you understand what type of problem is this, you can go ahead and choose models. For example, if you're using scikit-learn framework, you can go ahead and click over here. You will be able to see all the classification models that are available within this classification. And if you want to apply regression models, and if your problem is a regression problem, then you can choose all the regression models. And if your problem is clustering problem, you can go ahead and choose clustering models. So see, just to let you know that there are quite a handful of models, not many models, quite a handful of models like linear regression, logistic regression, SVM, random forest, decision tree forest, XGBoost SS. There are a couple of them popularly which are popularly used, and you can go ahead and learn about those things. But don't worry, I'll be creating many more blogs for and giving you insight about all of these things. And also, on top of stats, probability, and algorithms, you need to have data science skills. For example, if you have this raw data, like if you have this huge volume of data, how do you collect the data? How do you clean the data? And how do you make sure that you have proper data using which you can go ahead and build a model on top of the clean data? So in order to do that, scikit-learn again provides you pre-processing wherein you can go ahead and process and clean your data. So you need to have a bit of these data science skills as well. Now let's understand what is deep learning and how is it different from machine learning. Like how we have used algorithms in order to implement machine learning models, here in deep learning we make use of neural networks. And this has significantly changed the AI world. We are able to implement uh, use cases like object detection, video analysis, image analysis, and this is a game changer. And it has evolved throughout the years. It started with perceptron, and then with feed forward neural network, and then came the convolutional neural networks, mainly for images and image and video analysis, and then the recurrent neural networks, mainly for natural language processing. And then finally, we are in today's era, which is Transformers. Transformers is a game changer, and I have a dedicated video coming for you explaining every bit of Transformers, like what is an encoder, what is a decoder, what is self attention. So, yeah, I've explained this at a very high level over here, but we'll be deep diving in our upcoming blogs. And finally, large language models. Today, everyone and every corner we hear about Gen AI models using LLMs. So I have explained here what are LLMs and how we have made use of transformers in order to build these large language models, and what are the popular LLMs like GPT-4o from OpenAI, Gemini from Google, Llama from Meta, and many more models. Finally, now that we have understood like how it has evolved from machine learning to deep learning to transformers, the one more most important topic is MLOps. Without MLOps, there's no production model. So MLOps is very important when you want to go ahead and productionize your model. Now that you have understood, now that like, you have learned what is like how do you process your data, how do you clean your data, and how do you go ahead and build your model on top of the data, maybe a machine learning model or a deep learning model or maybe an LLM model. Now once you have all this ready, how do you go ahead and implement an end-to-end pipeline for your model? So that's where MLOps plays a major role on automating this end-to-end pipeline. And for that, I've given you for that we'll be deep diving into cloud platforms like Azure, AWS, and Google Cloud, using which it is very easier for you to implement an MLOps, like machine learning operations like deploying, versionizing, monitoring as such. So finally, I have explained over here the tools and platforms that you need in order to go ahead and implement end-to-end AI applications. Like you need Jupyter Notebook, which is very simple and intuitive. You can write your logic and you can see the output then and there. You can go ahead and install Anaconda and make use of Jupyter Notebook over there. Or in case if you need GPUs or CPU, like in case if you want to build deep learning models, which consumes a lot of compute, then you can go ahead and make use of Google Colab, wherein they provide you GPUs and TPUs, and you can make use of Jupyter notebooks within the Google Colab and write your code. Also, if you want to expert like now that you have understood about all of these topics, and if you have not got any use cases but still you want to go ahead and get a data set, you want to see group of people creating or what type of solution they are coming up with, then Kaggle is the best site wherein you can go ahead and take the data and see what how people are coming up with the solutions. You can participate in Kaggle competitions as such. So go ahead and make use of this wonderful website in order to go ahead and do your use cases. As already told you, make use of Azure, AWS, or Google Cloud to go ahead and implement your end-to-end MLOps. I've also referred you some of the books using which you can expertise in machine learning, PyTorch, or large language models. This is like, I'll be covering most of these in my videos, but then if data science is vast, like to be real, it is vast, and there's like it's a ocean. You can learn a lot of things from a lot of resources. So if you are a person who loves reading book, then please go ahead and take these books on machine learning, deep learning, or LLMs. You can just become an expert. But then yeah, you need to make sure that you practice and you implement whatever you learn. It's not just that you go through the theory, understand the theory, and you don't do it practically. It's very important for you to do practically whatever you learn. So finally, I've shared you all the links that I've explained here in this my blog. I've put all the links together over here so that it's easy for you to refer. Finally, last but not the least, you can send me queries to kalpa at aiconnectgrow.com. You can follow my YouTube channel over here, and you can also follow me in LinkedIn and message me over here and give me feedback and on how I can improve my videos, what topics you want to know in order to go ahead and learn further as such. Okay. Thank you so much, guys. It was nice staying with you and helping you out in order to learn um, all these newer technologies. But yeah, don't get overwhelmed. Start step by step. It took me more than 8.5 years to become an expert in AI, and I think in today's world with all these LLMs, everything coming in, it's not very difficult for you to become an AI expert. So just at a high level, understand about these topics at a very high level, and then I'll be guiding you in my further blogs on how you can go ahead and uh, take up each use cases and implement the use cases so that you have the practical knowledge as well. Thank you so much. Have a good day. Bye.